So we're going to finish up with a kind of a classic example that uses a Venn diagram. There's a similar example of this in your textbook. So let's give you the events m and n such that the probability of m is 0.5, the probability of n is 0.3, and we have this abstraction here, the probability of not m intersecting not n is 0.32. So before we talk about actually trying to answer this question, let's get inside trying to model what's going on here. So a classic way to start this kind of Venn diagram problem to bring some clarity to your setting is to say, well, firstly, I don't know what's going on in terms of like the overlap, so let's just call that x. But I do know that the chance of being, inside of m, I do know that that's actually 0.5 altogether. So 0.5 minus that little piece there gives the rest of this, right? And similarly, because I know 0.3 overall is the likelihood of being inside of n, well then 0.3 minus this little portion here gives you the rest of this. And you can actually see if you add these two together, the x's would cancel and you would have just the 0.3 that you expect. If you add these two together, the x's once again would cancel and you would have 0.5 inside of m. So that's consistent. What is this trying to say? This is trying to say if you say everything that's not in m, and sort of if you were to kind of consider everything outside of the realm of m, and then consider its intersection with everything outside the realm of n, you'll find that you'll just get this outer part, and that's what this 0.32 stands for. So a nice way to unravel the system to try to answer these two questions is to say, well, of course, these pieces, right, this plus this plus this plus this, these are all probability values, they have to sum up to be 1. And so here we are saying exactly that. This piece plus this middle piece plus this piece plus the 0.32 has to be 1. And then so you get some x's canceling, you get a little bit of arithmetic involved, and you flesh out that this x value in the middle is 0.12. Well, if that's 0.12, 0.5 minus that gives you the balance of 0.38. And again, 0.3 minus that gives you this balance here. So now you've got everything you need to try to answer some questions. So what's the probability of not m intersect n? Well, the not of m would be everything outside of m. And as it intersects with just n itself, you're going to pick up just this piece here. So that already answers that question for you directly. And what about trying to determine with reasons whether or not m and n are independent? Well, independent events requires that the probability of the one event and the other is the same as the product. If I go back here and say, well, what's the probability of m and n? We've established that directly. It's right in here because that's the intersection. It's 0.12. But if you consider 0.12 in relation to saying, well, is it the same as 0.5 times 0.3, which is 0.15? It clearly is not. So you're able to establish that we're not independent, and that's the reasoning behind it. Okay, that was a lot. I realize that. We went through some of the basics of this. These formulae from your formula booklet. Conditional probability is coming later. Final note is notice how similar these are with so-called combined events versus mutual exclusion. If there is mutual exclusion, which means that the intersection is an empty set, so imagine this piece here falling away, and that's why you get that these things would look very, very similar in the case of so-called mutual exclusion, if you don't need to subtract out that so-called overlap, which we saw twice in some previous examples. So that's it. More later. Bye.